Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Well fellas, now we're gonna solve question number 3 of this question paper. So if you have missed the previous solution, don't worry, I'll put the link to the at the end of this tutorial. So stay along with me, okay? Be bear with me. So actually question number 13 is similar to question number 12 if you have solved, okay? So in here, let's read the question. What mass of water in gram is produced during the complete, may I repeat, complete combustion of 0.02 mole of octane? Okay. So let's just construct an equation. Okay. So if we react octane, which is C8H18 plus complete combustion means it's reacting with we are reacting octane with oxygen. Basically combustion means we are reacting octane with oxygen, that's it. So we are reacting okay, so here we are reacting this with oxygen, giving off, since this is complete combustion, we gonna get we gonna end up getting carbon dioxide plus water. Okay, so here we have constructed a chemical reaction for chemical equation. We have constructed chemical equation for the complete combustion of octane. Okay, so now let's balance the equation. So if we balance the equation, here we have 8 carbon on the left hand side and we're gonna have 8 carbon on the right hand side. So carbons are balanced, carbon are balanced on the left hand side and on the right hand side. Okay, so now let's balance hydrogen. 18 hydrogen on the left hand side, we're gonna get 9 to the 18 hydrogen on the right hand side. Okay, hydrogens are also balanced. The only thing here we are left with oxygen. So now let's count the number of oxygen that is involved here, over here. Okay, so let's just count the number of oxygen atoms on the right hand side. So here 8 to the 16 and 9 oxygen, 16 plus 9 gives us 25. So we have 25 oxygen on the right hand side, so we should have 25 oxygen on the left hand side. So for that we're gonna introduce a fraction on the left hand side. Okay, so since we have 25 oxygen on the right hand side, so we should have 25 oxygen on the left hand side. So for that we gonna introduce a fraction 25 divided by 2. Therefore these two cancels out and we gonna end up getting 25 oxygen. That's how we gonna do. So the number of moles of oxygen is 25 divided by 2. Okay, so we are not concerned with this oxygen, we are concerned with the water, the number of moles of water. Okay, so here the number of moles of octane is given. So we just gonna use the mole ratio. So the mole ratio of octane with water is 1:9. Okay, the mole ratio of octane is to water is 1:9. Okay, so now therefore the number of moles of water should be let's just do a little bit of arithmetic. Okay, number of moles of water is 9 multiplied by 0.02, which is 0.18. 0.018. Okay, so we have found out the number of moles of water. Now we're gonna find the mass of water. So therefore the mass of water, we know the molar mass of water, which is 18 gram. 18 multiplied by 0.018, which will give us as this one, C. So therefore the answer is C. Okay, so fellas, that's how we gonna do. So in order to solve this type of question, first we need to construct the chemical equation for this reaction. Okay, the chemical equation for this reaction, we're gonna balance it, and then we're gonna find the mole ratio, we're gonna find the relation of mole ratio, then we're gonna do as we're told. Okay, as it told, as the question says, we're gonna do as the question says. Okay, so that's why the answer should be C. Okay, so fellas, that's the solution to question number 13. So if you have any question, if you still have any confusion, if you still have any confusion regarding this thing, please let me know in the comment below. Okay, now let's move on to the next question, that is 14 question number 14. Okay, it's about combinatorial chemistry. Which is the most important advantage of combinatorial chemistry over traditional methods for developing pharmaceuticals? Okay, so this question says that what is the most important advantage of combinatorial chemistry over traditional methods for developing pharmaceuticals. Okay, so what happens, let us first know what happens in a combinatorial chemistry. So here we have synthesized one chemical. So from this chemical we're gonna multiply this into several chemicals. From here we have found three chemicals here, 1 2 3. Okay, and here we have, okay, let's just break it down into two. I don't want to make this complicated. Okay, so here what is actually happening, so from one chemical we have synthesized two different chemicals. Okay, 4 different chemicals. So from here we have a pair of a new chemical, and here a pair of new chemical. So from here we're gonna move on making other two chemicals, just like this, just like this, just like this. So here we are finding the possible chemicals that we can make from one chemical. So from here it divides just like this, it divides on and on just like this, and that's how we're gonna do. And from here if we find one useful chemical, just for example we have found out these two chemicals, this section of chemical is useful, so now we're gonna leave all these chemicals in the trash, and we're gonna research this thing to make useful medicine. So that is how the pharmacist carry out research by doing this method. So here we can see that we can create a lot of varieties of chemicals in a given time by combining, by what does this say, what should we say? Here we have divided, we have formed a multiple chemicals just using one type of things. Okay, so that's how it is done. So many more compounds can be made in a given time. So here we have created many more compounds in a given time. Okay, so we have just synthesized a lot of chemicals, a lot of possible chemicals from a given chemical. Okay, so that's the explanation. So many more compounds can be made in a given time. So here the main objective of combinatorial chemistry is to synthesize a multiple amount of chemicals from one chemical. Okay, so we will form multiple chemicals, and we're gonna research on the chemicals which is useful. We're gonna find which is useful. That's it. That's the spirit of combinatorial chemistry. Okay, now let's move on to the next one. Okay, so here in question number 15 it says Linalool Linalool. Okay. Lina li li no Linalool. Okay. Linalool is an organic organic liquid that is immiscible, that can mix with water. Okay, what is immiscible? Okay, don't mix with water. So this particular lina lina linalool, okay, linalool doesn't mix with water, okay, and can decompose below its boiling temperature. It is extracted from lavender flowers. Nice smell. And stalks. The lavender flowers and stalks are crushed and mixed with water. Yay! Which is the correct order of practical techniques to extract linalool with its mixture? Well, it is good to mention that it would be appropriate to mention that linalool, this particular compound doesn't mix with water and can decompose below its boiling temperature. Okay. So which is the correct order of practical techniques to extract linalool from this mixture? So here, first of all, linalool is immiscible with water, don't mix with water, okay, and second of all, it decompose below its boiling temperature. So for this condition, we gonna carry out steam distillation. So we carry out steam distillation for those which are immiscible with water and can decompose below its boiling temperature. That's the main motive of this separation technique. Okay, so these are the possible choices. These two are the possible choices. We carry out refluxing when we deal with volatile reactants. The reactants might get volatile. The reactants can be evaporated easily while reacting. So we carry out refluxing for volatile reactants. Okay, we use a separating funnel when we have two immiscible liquid, just like we want to separate oil from water. So for that we will use the separating funnel. Okay, or we may use separating funnel for separating precipitate from water. That's it. Okay, we can use separating funnel for separating precipitate from water or solution. For separating precipitate from the solution, we will use this technique using a separating funnel, drying, decanting, distilling. Okay, we're gonna use option D for separating precipitate from the solution. Okay, and we're gonna use refluxing when there are volatile reactants are involved. We're gonna use refluxing, distill. Okay, here we're gonna use, in this case we're gonna use steam distilling. Okay, it would be either B or C. Okay, let's see. Let's further inquiry about the process that we should do. Okay, so steam distilling, purifying by washing, drying, decanting. Okay, steam distilling using a separating funnel, drying, decanting. Okay, so I think the answer, can you guess? Okay fellas, can you guess which should be the answer? It's a difficult choice, right? I can see. It's taking time. Which should be the answer? Is it B? Is it C? Is it C? Are you sure that it should be C? Yeah, you guessed it right, fellas. Yay, we have found the answer. The answer should be C. Okay, why the answer is C? That's because first of all, this is an organic liquid. Linalool is organic liquid. Okay, second of all, here on the second step we have carried out in option B. In option B, in the second step of option B, we have performed purify by washing, and this thing is only done when solid is involved. Okay, so we don't do this with liquid, we don't mess with this thing with liquid. Okay, solid is involved. Here we can see that it is already immiscible with water, and again purifying by washing means we are again adding water to the linalool. How ridiculous. So that's why we gonna stick it with option C. That's why we're gonna stick it with option C. Steam distilling using a separating funnel, drying, decanting. Okay, since first of all, linalool is an organic liquid which doesn't mix with water, first of all. Okay, so that is why we don't want to purify again with water. So that's why we are not using option B. That's because if we purify by washing, that means we are adding more water to this linalool, which is more unexpected. Okay, fellas, am I successful to break it down? Hope so. So fellas, we will stick up to the option C. So the answer is option C. So here we gonna use steam distilling using a separating funnel, drying, decanting, finish. The case is closed. Okay, so fellas, that's the end of this solution. The answer is C for 15. So fellas, the answer for question number 15 is C. Okay, so fellas, I hope that you have understood the question as well as the solution. In this solution we have completed 3 questions. One is question number 13. The answer of question number 13, let us review the answer of the questions that we have done. The question that we have done is 13. First we have done 13. The answer for 13 is C. Okay, and the answer for 14 is A. I forget to write, sorry for that, fellas. And the answer for 15 is C. Yay. Okay, so fellas, that's the end of this solution. So yeah, stay cool, stay awesome, best of luck for your exam, and as always, peace with chemistry. Oh, I have forget to give you one thing. No, we are not done yet. Thanks for watching this, fellas. It's really lot to me. It means a lot to me, fellas. Thanks for watching this, fellas. Congrats, fellas, we have made it till the end. Help us improve our lessons by giving your feedback. Okay, so you may give this video a like or dislike, both of them will appreciate it. So let us get 100 likes on this video or 100 dislike on this video. Let's see which one we will get. So don't forget to leave a comment about this video. How was it? Was this video tutorial helpful to you? Should we make more video like this on future? Okay, and help me improve the quality of this video. Okay, ask any question. If you have any question regarding this topic, or if you have any confusion regarding this topic, please let me know in the comment below. Okay, so if you find this solution helpful, here are the similar solutions like this one. Okay, so if you have missed the previous solution of this question paper, don't need to worry. I'll here I'll okay, here is the oh, sorry, I burped. Okay, sorry, that's disgusting. Okay, so here are the similar solutions like this one. So